We had seen before that in a rhombus, a parallelogram with four sides congruent, that the diagonals intersect, making a right angle. We can play with dragging the vertices here and noticing that the sides keep being congruent. Of course, opposite sides are parallel. That's what it means for it to be a parallelogram. And the right angle here is always there. That those two diagonals intersect, making a right angle, even if we make it smaller or if we make it bigger. That's a property of rhombuses. Another property that is important to remember for these rhombuses is that diagonals bisect this diagonal right here, bisect the opposite angles. So you can see that these two angles measure the same, 27 and 27. So those two are congruent. So are these two, 27 and 27. And same thing happens with the other diagonal. So that is to say that this diagonal here bisects the opposite angles, right? So each diagonal bisects opposite angles, and you can move it around and you can probably change that angle, but you still notice that it is those two are congruent. In this case, 77 and 77. So that's also important to remember. These four angles will be congruent, and these four angles formed in the other diagonal also will be congruent. But now we want to talk about rectangles. What is the special property about rectangles? Well, the main property about rectangles is that their diagonals are congruent. So you see the distance from A to C is labeled here. Distance from A to C equals 13. And so is the distance from B to D, also 13. So if you played with dragging the vertices, you can make the rectangle smaller, but you can still notice those two diagonals are congruent. So in general, the parallelogram is a rectangle if and only if diagonals are congruent. All right, so that's the property we want to keep in mind. That also lead us to the next property. Let's see, next theorem right here. I'm hoping that it'll show up at some point. Well, okay, yeah. Well, so what you can expect from there is that, of course, since you know that the square is the marriage between rectangles and rhombuses, so it inherits properties from both. So in order for you to have a square, you will need diagonals congruent and also perpendicular. All right, so, and you will see, of course, that diagonals will bisect the opposite angles. In here is, even though it is not measured, you can tell that this angle right here, the angle BAC, is not congruent to angle CAD. So that's telling us that this here is not a rhombus, and it's clear because this side right here is shorter than the other side, and in a rhombus all sides are congruent. So what makes it a rectangle is that diagonals are congruent, but those diagonals do not bisect the opposite angles as they do in the rhombus. So again, combination of properties of rectangle together with properties of rhombus is what determines if it is a square or not. So we'll do some problems here on IXL. For example, here it says, is this parallelogram a rectangle? So knowing that these four segments are congruent, I can tell that this diagonal FH and diagonal GE are congruent, so I can guarantee this is a rectangle. So I will say yes. Go to the next question. Is this a square? Let's see, we gotta check two things. Diagonals congruent, which they are, and also perpendicular. So the fact that diagonals are perpendicular tells me that this is a rhombus, and because diagonals are also congruent, then that makes it a rectangle. Since it is both, then I can tell surely that this is a square. Now they are asking me about this quadrilateral and asking me if it is a rectangle. And I see here this piece is 49 and this piece right here is 46. So that means that diagonals are not congruent. So if diagonals are not congruent, this cannot be a rectangle. So now they will ask me if what is the value of A for this to be a rectangle? It is a rectangle, we know that. So QT is 17A and QU is A plus 32. And those four pieces, TQ, UQ, QR, and QS, are to be congruent because this is a rectangle. So 17A equals A plus 32. And if you solve that equation, you will get that A equals 2. So you can ask me in class how to get that number if you need it. But now, is this a square? Clearly, diagonals are not perpendicular. They are not making a right angle. The angle is 95 instead of being 90. So I know this is not a square. We'll do more problems in class, but this is the actual skill that we will practice in class end of 9. So if you want to get ahead of the game, you can work on it. And that'll be our focus for Monday's class. So I will wait for you guys with questions in case you have any.